My name's Andy Parkin, Managing Director of the multi-award winning Speed Screed. I'm here today to talk about Self Leveling Screed Thickness. So when we talk about self-leveling, I think if the truth be known, there isn't a self-leveling product out there, because I think you could literally pour a load of screed in the corner of a room and it wouldn't level itself. I think you've got products that are self-smoothing and self-compacting, but I don't believe that there is really a true self-leveling product. I think if you was to, you can use a trowel, a notch trowel to lay some of the smoothing compounds, and that's a very good way. But you're needing some assistance with that to get a certain minimum depth. So, but we often refer to them as self-leveling. So they are self-compacting products. So when you look at the minimum thickness for these products, you need to look at the different types of construction that they're going on to. And first of all, you've got bonded. So bonded is going directly onto the substrate. So the substrate being in situ concrete, it could be precast beam and block, it could be precast planks that it's going onto. So it's bonding to the surface. So the two products meet, and there is generally a compound, a bonding agent that's in between those two products that makes sure that the two bond. The other type, or another type of construction, is unbonded, and that's when you have a membrane in between the substrate and the screed. And lastly, there is floating construction, so that's when you have acoustic insulation or thermal insulation, and the screed is going on top there. So effectively, the screed is floating. So the thicknesses will change depending on which, or the minimum thicknesses will change depending on what the type of substrates are. So if we look at each of those types individually and look at the products that are generally available. So if we're looking at bonded, so when we bond into a substrate, we need to make sure that it's clean, that it's sound, that there is no dust, etc. on there. It may need some mechanical preparation. We also need to check that it's actually dry. In situ concrete slab can hold moisture for up to 12 months. So it may be that a moisture reading needs to be taken to check if the substrate is actually dry. So that's a consideration as well when you're bonding. So for a smoothing product, so that can go down, so a smoothing compound can go down really from feather edge, and it could go up to typically 10 mil, but there are products that will go up to 50 mil. You would question about the cost of those products at those particular depths, but there are products that will go. So there's products with different ranges. For a calcium sulfate product, so that can be bonded from 15 mil. Now that is a specialist calcium sulfate product. So as I say, that can go down from 15 mil bonded. And if you're looking at the general calcium sulfate product, that would normally be 20 mil. So you've got a good range of products there that can go down. You would always think about holes, making sure that the material doesn't potentially run away, that any joints in the substrate are mirrored through if you're bonding. So they're just some considerations to take on board. The next type of construction is unbonded, so with the membrane. So with the specialist smoothing products, and we're talking really about a calcium sulfate product at 15 mil. So there's a calcium specialist product that will go down to 15 mil, and it will go up to effectively 80 mil if required for that. I think if it was going up to 80 mil in an unbonded situation, you'd probably just use the general product. So the calcium sulfate flow screed, just a general calcium sulfate, which would actually go down to 30 mil unbonded, but you could go up to 80 in thickness and would be more cost effective than the other product mentioned. So in the floating construction, so if it's going on top of insulation, you'd always look to put a membrane on there. So if you're laying on top of foil back insulation, so you're not getting the reaction that produces hydrogen bubbles on there, so you wouldn't want it directly onto foil back insulation, and of course you don't want to lose any of the product. So a membrane just nicely retains the material where exactly it should be. But a general flowing screed product will go down to 35 mil domestic and 40 mil commercially. Now, if you introduced heating pipes in there, so again using the calcium sulfate, some people call it flow screed, some people call it liquid screed, but its binder is calcium sulfate. If you got the heating pipes, which the heating pipes are generally 15 or 16 mil in diameter, you may get other systems with trays, etc., that you may be able to go even lower with those, with the specialist trays. But generally, when you're clipping in to the insulation, you're looking at the flowing screed. The calcium sulfate needs to be 30 mil above the pipes as a minimum. So on a 15 mil pipe, that would be 45 mil as minimum. There is a specialist calcium sulfate product as well, and that actually goes down to 20 mil above the pipes. So in total, you'd be looking at, if it was a 15 mil pipe, that would be 35 mil of depth at minimum, of course, from the highest point within the floor. I hope that's been of some use. If you've any further questions, please feel free to contact us, and we'd be happy to answer any questions that you may have. Thank you.